आफ्नो नलेजलाई सेयर गरिदिनु पर्यो भनेर चाहिँ रिक्वेस्ट गरेका थिए र त्यो हाम्रो रिक्वेस्टलाई उहाँले मानेर आज हामी माझमा चाहिँ HAZOP Hazard and Operability भनेको एउटा यो चाहिँ तपाईको रिस्क एसेसमेन्ट टुल्स हो हैन यो एउटा सिस्टमेटिक टुल्स हो त्यसको बारेमा चाहिँ कुरो गर्छौं भनेर उहाँले चाहिँ भनिराख्नु भएको छ र हामी त्यो कुरोमा गइरहेको छौं It is our pleasure. We have Ashok Gulati sir to share his knowledge. He is working in the OSS field since he graduated from the IIT Kharagpur as a chemical engineer. Since last 35 years, he's working in the many multinations company, and as I know, he has a very, critical work he has done in some industries. So he know the values of safety, because as he shared with us, single drop of chemicals, if it fall down from his workplace, it will have a disastrous effect. So he managed to work on such a, critical situations also. So it is our pleasure. He is willing to contribute his experience to all of us Nepalese OSS professionals today. I would like to request him to start his sessions. And if you like to say something also, sir, you can add on that. Thank you, sir. Thank you for coming, for contributing us. This is start, sir.
Thank you, Mr. Kangal. In fact, very nice seeing your face and being on this occasion with you all and your colleagues. In fact, it's a great pleasure for me personally. Okay, thank you so much. Okay, before I commence this, I only need to know one thing. We have about now 21 participants. All these 21 participants are from Nepal, or are they from other part of the world?
All are the Nepalese, sir.
Okay, Nepalese, but probably living elsewhere also, not only in within.
Yeah, mostly I think I'm sure that 20 participants are living in Nepal. What's about the Uttam ji? Uttam Budathoki ji?
He's from UAE. He's from
okay,
UAE.
What is the Nepalese? He is working in UAE.
Okay, fine. Who's from UAE? His name is?
Uttam Budathoki, I think.
Uttam. Okay. In UAE, Uttam, where do you work? In kind of what job or what business or what activity you are enrolled in?
Tom ji, hello Tom.
We have seen him online, but he is not audible, sir.
Okay, yeah, right.
He's working as a OSH SHE personal in one of the industry over there, sir.
Okay. Okay, HSC manager or
safety engineer
in the similar. Yes, yes. Yes, you're working as?
Safety engineer.
Engineer, okay, very nice. Thank you. And others in Nepal, I obviously whether you are in the inspectorate or you are in the industry or you are a consultant yourself or you are in some chemical industry or whatever the other industries. So whether you have a design background or operational background or only HSC management. So I believe that is what the field is, but every one of you have interest in health and safety management. That means somewhere connected with health and safety management. That is what I understood from Mr. Khan. I will not take time in getting personal introductions. Okay, we will get on, but feel free to ask and feel free to share. Okay, anyone can actually ask any questions anytime, and anyone can actually share whatever he wish to share. Okay. So can we start? I need to only see the chat box because in the chat box, I want people to actually put in their some questions I may be asking. The answers to those questions, they need to put down in the chat box. Okay.
Okay,
Because
sir.
this
Okay, sir.
technique actually helps us to, there's a lot of question, answer. We deliberate between us. So that need to work well. So in fact, so I need to make that as a live function. Okay. So if I put this chat box,
Is that clear, sir? It is.
yeah,
We have
I think
here.
it's okay now.
So, is there any problem, sir?
Yes, the screen share is showed up. You saw the screen top and then I think it is vanished. Okay.
Screens here.
Screen sharing has failed to start. The window selected is invalid.
I have already given the access to screen share, sir. You can do here, please.
So,
Yeah, that's fine.
yeah, yes.
You're able to see the screen now?
Yeah, sir.
Okay.
Yeah, it's good. Yes, sir.
Oh yeah, we can see your
It's
screen.
visible, sir.
Okay.
You can go ahead.
What I'll try doing it is because the main will not, the whole thing will not come as a uh, just 1 second. chat has vanished, right?
We can go to full option as well. I think we have to go in the slide option, so slideshow option. If you show the slideshow, then everyone can see in the very larger picture.
So when I'm seeing the slideshow, okay, then active chat box vanishes.
Okay.
Okay, it's also okay, sir.
This is it okay? You
Yeah,
are able to see?
it
Because
is
if
also
if I do
visible.
this chat box, this slideshow,
Hmm.
yeah, now
It's fine.
this is fine, right?
Yeah.
Okay, welcome all. We get straight into our subject to discuss. Okay. Um, what HAZOP, as title is known to you, Hazards and Operability Study. Actually, this was developed technique in ICI in UK, and during the late 60s. Why it has become since then a very important technique for identification of hazards, and in particular design related hazards. Okay, so we have this technique is for most powerful in terms of identifying design related hazards. um, why ICI did feel it, because early in the 60s there have been many major incidents took place, and ICI was actually a design company at that time. It was not only manufacturing, but it was also one of the major chemical design company, was one of the foremost design company at the time. And so they got convinced that something needs to be happening, because many fault or many flaws which investigation threw up, it showed that enough care had not been taken. Okay, that means designer may have known, but actually it was not fully used in actual design. So there were many questions on that which actually came out from the major incidents. So they got convinced on that. This technique was formalized, and the first was Indian Chemical Industries Association of UK made it a code, because ICI, instead of keeping it only to their own self, they shared it with the whole world, and first within their own country. In that country, actually, it was made a code, and that was even way back in 1977. This technique actually engages asking certain questions. These questions actually will reveal where a possibility of deviation is there or not. So we'll understand this a little more as we get into this. And since then, it has been applied in not only in ICI, but all across the world in all industries. In fact, it is now part of OSHA, even in America, of this. That means one needs to do it, and it's a mandatory requirement for all designing companies to do this before freezing the design. That means when you design a new plant, new chemical plant, it should be safe to work. That means it should not be possibility to cause any unsafe situation within the plant. So that means my design should be safe. For that matter, this technique is adopted, and it has become a rule for all design company to mandatorily do this. Okay, what and how it goes further is Trevor Kurtz is a gentleman some of you may have heard. He was actually probably the big, the most wise, wisdom-wise, or well-known authority. In fact, I don't think the world has seen equivalent safety professional equal to Trevor Kurtz. He has written many books. He was a professor. Earlier, he worked in ICI, and he made the comment: few accidents occur because design team lack knowledge, but most occur because design team failed to apply the knowledge. Okay, so this was his comment on this. Now, what is this HAZOP? When we design a plant, we also know that we have material, we have equipment, we have piping, we have instrument, we have electricity connections, we have electronics in it, we have pneumatic in it, we have a human part of it, and there are many different functions combined to make a plant and operate that plant. Okay, so point is, if I have a hazard, let us say I have some kind of flammable, maybe hydrogen, or maybe highly explosive gas mixtures, and even a small ignition can actually cause a small, it could create a fire. So I need to actually manage it. How do I do? In other words, there is electricity. There is a hazard cannot be eliminated because hazard is part of my chemical process. But I need to, electricity is there. Maybe I'm running a motor, which is agitating motor, and there's something in the liquid, and hydrogen is evolving. A hydrogen gas gets evolved. Like we have lead batteries and hydrogen is evolved from that. But supposing I was in a manufacturing activity and hydrogen is coming out and it can catch fire. And motor, I need agitation to take place. Now point is how to prevent hazard of electricity or coming in contact with my chemical hazard. It is a potential problem. So the point is I need my other functions to come in. If the other person who says, okay, don't use electricity, use pneumatic motor. If I use a pneumatic motor, then electricity is absent. So that means I have solved my problem in that. So, so this is one part. Or if I'm having some other mechanical equipment where there's electricity also there, but if I keep metal because I need a sturdiness, but on the other hand, it can any touch with the body can create a electrical shock. So that kind of things can create a major issue. So what we do is we may have somebody else, plastics, for example, plastic can be made hard enough to sustain, thick enough and all that, and plastic is not going to actually conduct electricity. So in other words, the point which I'm making by these two examples are there are different functions. All these functions come together to solve my hazards. One function alone cannot solve. Okay, so we need different functions to come together, interaction different function. And second thing is, when you design a plant, you actually don't do what has already been done in the past. Sometimes the technologies are new technologies coming up. For example, today, some of the technologies which are coming up are on nano-based particles. I have a nano aluminum particles. I have nano, you can say, the because silver particles. They do tremendous amount of work. Okay, so when I'm using a new technology, then I don't have a past experience to, you can say, duplicate. So I'm getting into new areas. I don't have the human being or humanity does not have experience in that field. So how do we do it? So I need to design a plan for the future. So we are at times faced with that situation. Okay. So point we are talking, and we need to do it proactively in the sense there is no point of making a mistake and then actually rectifying it. So I must design so that nothing should go wrong. If I design that it can go wrong, then it's not a good design itself. So point is, we have challenges, new situations to face with. We recognize the multifunctional approach is the best function. This is true. But once we have one point coming up here, point number 3 under that, deviation from design intent are looked at. It is in a way assumed, but assumption is valid because when supposing you are satisfied with a particular design as a design team. So if everything works within the parameters of control, then nothing should go wrong. The assumption is only this: I have designed whatever is being specified in terms of equipment condition, in terms of parameters of operation. All of those parameters operations are within limit. If everything is within limits which is specified by the designer or process licensor, then it should not create any incident. Now, this is the assumption which you are actually going to make. And normally, this is quite valid because you apply your knowledge and put it in practice. And that means if you have fully used your knowledge and come up with a design, then within the permissible limits, nothing will go wrong. Things go wrong because we deviate from the limits, across the limits. We go either more than the limit or we are less than the limit. Limit is always a certain range. So that is what we're going to do. So we're going to actually find out how deviations take place. Okay. If you look at the history of any particular plant, and in fact, this whole thing started with the chemical industry, though this technique has been later on extended to other fields of industry. And so ICI actually had come up with 6 hazard studies. Hazard study 1 is carried out at the earliest opportunity of the project, when you're conceptualizing a project, what you want to make, where will you make, what volume will you make, what production level that you're going to plan. So locating industry and choosing a process of manufacturing has a lot of its own hazards. So when you are actually designing, looking at that, there is a hazard study one, because many of the hazards later on are experienced, but he says we already exist here. We should have cited our site somewhere else. Now, or we have gone for this volume of the manufacturing scale. How big should the plant be? Should it be 10 tons per day, 100 tons per day, 500 tons per day, 1000 tons per day, or 2000 tons per day? What is the limit and how do you decide that limit? So what is the optimum production level which dictates from safety point of view? It is not the market, because I can, if I would need to make 500 tons, I can make it 250 tons per day, two plants, both similar, parallel kind of things. If optimum is 250. So I can actually do that instead of setting up a one plant of a very large capacity. Because larger the capacity, bigger is the hazard. So hazard study one is at that stage of conception where the entrepreneur or the company who's planning to set up a new plant actually has to carry it out. Hazard study two is carried out before the pre-sanction stage within the company, and that is where you look at more detail. That means how much storage capacity will be there, how much, where will be my fire center, where will be my roadways, roads coming, how will I get my raw materials, unloading. So I have a general more clarity about the details. So that is where hazard study 2 comes in. Hazard study 3 is what is known as HAZOP, and hazard study 3 is done once P&I, process and instrument diagram, is actually made out. P&I diagram is basically the design of the plant. When we have made the initial design of the plant, that means design is formed up by the design team and then offered for further approval. Once you are at this stage, that the design team has produced a P&I diagrams, all the P&I diagrams relevant, and it is now seeking sanction that this will be formed up. That means all controls, all instrumentation is built in, all the process elements, connectivity, all built in. This is where normally we say the design is made. Okay, that means design team has done his output and given it. Okay, so when we need to check it, do the HAZOP study 3, this is where stage is where we do it. And this is HAZOP. But later on, there's a hazard study 4, and that is done before the commissioning. Then, this is done when the construction is complete. Okay, and so you look at what the hazard based on the construction. Okay, installation, constructions, and those kind of things. There are other pathways or accessibilities. All of those are actually looked at. And hazard study is just before commissioning. That is hazard study 5, and hazard study 6 is while a plant is operating and building the experience in plant. Okay, this is shows up on your stage, project exploration stage, preliminary project estimate. That's when we estimate. So stage hazard study 1. Project definition is well defined. Project is defined 2, and P&I at the time of making procurement, because after that procurement will start. That is 3. Construction 4, and before commissioning 5, and last is normal operation. Okay, I want to ask one thing at this time to all of you. You able to hear me and able to get me? Any questions you wish to ask?
Uh, yeah, we are getting you, sir. It is
Okay,
okay.
thank you, Karen. Anybody else? Anyone else who's,
Yeah, sir.
yeah,
Yeah, in some places I have seen the HAZOPs are being done after the project execution or during the plant operation. So, but as per your definition, HAZOP is done only during the design and procurement phase.
yeah.
So, so the study which is done when the plant is operating, so isn't that HAZOP?
Actually, supposing you missed out at the stage 3, which I've talked about, you are facing a situation where something is not satisfactorily performing, okay, or you have anxieties about it, okay. So at the stage of 6, you undertake a HAZOP, okay. So the technique can be applied at the stage 6 also, but then point is whatever you discover will actually be much more cost to rectify than anything else, because here if I need to change the design, you can't do it at the stage 6. You may do some modifications, some minor modifications, some prevention kind of things, or retrofitting kind of things you can do, but you will not be able to change basic approach. So it's like this: if you missed out at this early, then you are doing small areas. You are actually uh, taking care so that major things don't go wrong. So it is sensible to do at that stage of normal operation, but one should have done at the stage 3. That is what the and stage 3 doing does not mean stage 6 will not be done, because we are saying what you call HAZOP here actually is a hazard study which you need to do, which is not really the only the methodology of HAZOP. You will actually going to do other ways of identifying hazard. Yeah, hazard identification techniques, you will use them all. So there is a way to do hazard study 6, which is much more uh, different than only the HAZOP part. HAZOP is fundamentally meant for stage 3. I'm not saying that 3 cannot be done at 6, but it will give you less kind of benefits. Ravi, is that clear, or you have a question?
Yes, sir. It's clear. Thank you, sir.
Okay. Anybody else who has a questions to ask? I wish you, I mean, all of you to ask more questions, because there is one purpose which I see in your kind of, this kind of meetings that you have together is after this session, when it completes, maybe hour and a half or hour later, you should have one conviction, and conviction is where and how this technique can be applied and what kind of benefit it can give us. Okay. So if you have any doubt coming out in your thing, or if you're not getting the some information, not actually captured it, uh, please ask the questions. Because let me tell you one my personal experience. I worked with this. I worked in ICI, so I know the company from within. Okay, I worked in my career in ICI UK company, but in Indian subsidiaries. I worked in Indian Explosives Limited, manufacturing explosives. I worked in organic division. This is Alkali and Chemical Corporation of India. I worked in ICI's fertilizer plant. And since I learned it from the inventors. This technique was learned from the inventors. They came down to India and they actually explained us. I've been in HSC department for more than 10 years, where because of my position and because of this special training that I had received, I actually headed many HAZOP studies, conducted many studies as a leader. And we have gained a tremendous amount of benefit out of it. In fertilizer, for example, there is various changes which we did, major modification which we did, and all of them benefited us. I must also confess what Ravi mentioned earlier. Actually, when the plant was designed, obviously I was already in a working plant. So we actually did the HAZOP at the stage 6, but we applied it on specific areas. Okay, we applied in a specific area. Okay, and second thing, we had made one rule: whenever any change to my plant is going to be proposed, modification, maybe for other reasons, maybe my augmenting capacity or debottlenecking kind of things, or any change to the plant will need to actually undergo this technique before it's approved. That means modification will not be approved unless HAZOP is done and the recommendation of HAZOP are incorporated. In fact, that is a rule it was in ICI and is a rule in most of the today good companies. Okay, so I'm saying that there's a great benefit, but please feel free to ask questions on this too, whenever, because you need to actually have a conviction coming out. Okay, hope you
May I ask one question, sir?
Sure.
Not a question, but it would be nice, like you just have mentioned that you have worked in the fertilizer industry also.
Yeah.
We don't have, so it would be nice if you could give an example that what in the real scenario, what are the issues that you identified with the techniques of HAZOP. That would be nice because we have some fertilizer industries here we worked, and I would like to know.
Okay, but going into those kind of things, just wait for some time, because it will consume, because I want to actually first bring out the technique part well. Okay, and when
Let you
the
know.
time available, I will share that part of it, because if I get into that, it will take your attention away.
No,
So
at the end of the
yeah, that's
sessions, you
right.
can
Fine.
share that what are the most hazards that significant hazards that you identified, especially in the fertilizer industry, so that
Sure,
we could know about it.
sure,
Thank
sure,
you.
sure. We'll do that. There are such few terms which are used: intentions, deviations, causes, and consequence. We have intention is that when the plant is operating or is supposed to operate within the defined condition, it is safe. This is one statement we are actually normally would carry through. Okay. Second thing is, if whatever defined conditions under when and what can deviate, we don't wait for the deviation. We want to know what can deviate and what all can deviate. That means I may have various parameters or various things. What can deviate? Now, this ability to discover what deviations are possible, and all deviations are possible, that is what we actually look at. Okay, and so there is a deviation from the defined operating criteria. That means define whatever the way it's supposed to function or operate, that when it can go beyond that limit, outside the limit, that is what we are going to discover, and we will call that word as a deviation. then we are going to look at if this possible deviation, what are the causes for the deviations? Okay, both are connected, because if there is a cause, only then there can be a deviation. Otherwise, deviation won't take place. Deviation cannot take place if there was no cause for a deviation to occur. So we will actually look at the causes. Okay. On one side, we are going to look at the causes of deviation. If the cause is present, then deviation will be present. Deviation can happen. And if deviation can happen, because we have corroborated it with the causes, now we look at what is the consequences of deviation. So what if this deviates, what will it cause? So we look at the consequences. So we are actually going to use this 4 words as important term, and we will see as it comes up now. This whole technique goes around in guide word. That means there are a set of guide words which are spelled out, and these guide words are enough to identify all possible deviations. Okay, this guide word will be sufficient to identify or discover all possible deviation. Okay, we are going to have some examination session that we sit together in a group and do. This technique is not done by one individual alone. Technique is a different functional team get together and then do. Member 4 or 5 people are actually discuss together, and they come from a different backgrounds and different things. Okay, so there are team discussions on examination session, and they discuss among themselves. After that, there are certain actions which are decided, and evaluation and action sessions. So we take stock about what is decided, has that action been taken? Or because sometimes when we sit together, we find we do not have knowledge in certain area. When we do not have knowledge in certain area, then I need to actually go out of the meeting. Out of the meeting means I have to defer it, consult. If let's say I'm doing something and I find my one of the issues can be metallurgy of my material or construction is actually going to interfere. If that is going to interfere, then I don't, in our team, we did not have any person with that specific knowledge. So we will not be able to take the final decision then and there. So we actually go out, consult him, talk to him, get him, or maybe invite him to the next meeting. So there are certain actions to be taken, procure some information, get somebody in. So these are evaluation and action sessions, pursuing it on whatever you are actually looking at it. Now, technical team members, who are the technical team members? I'm going to spell it out just now. And one of them will be team leader. Team leader is not necessarily the, you can say, authority of the subject knowledge, knowledge about the process, but he is authority on the technique. He and actually makes sure that the HAZOP technique is followed through. Okay, so that is for study secretary is one who makes notes. Okay, now you can understand one thing. If I was discussing and I was inquiring and I also concentrating parallelly how to draft a proper wording it right and writing it there, my attention gets diverted to writing. So we need individual attention to be maintained. So we take normally is scribe or study secretary who actually is basically recording whatever is happening in the meetings. These guide words are spelled out here. on the thing. I think constitution of the committee, there's probably a slide later, I will tell you. Just 1 second. Yeah. Can you read this? It's a little smaller. Or let me read. Yeah. The preparation for the team. HAZOP team leader who ensures that the technique is followed properly in depth. There's a person who actually is involved in the design. So he knows the existing, whatever the design has been done. If the design was done by somebody else and nobody is present in the company who has done the design, then normally technical manager or technical, whoever knows the design, understanding of the design best, he becomes a member of the HAZOP team. So we can call it as a process design engineer. It is must for him to be present. Process commissioning engineer is like a production man who knows how to operate a plant, who knows how to run the plant. He may not be knowing the design basis of something like that, but he has good experience or best experience amongst the team who is involved in operating. Project engineer is either he has been is normally a mechanical maintenance man or project man. So we need someone from mechanical project or background. Okay, so this is maintenance, and as necessary is where we need. If I'm doing something on analysis, I may need a chemist. If I am doing something electrical and instrument, I may pick up an electrical man or instrument engineer. So this is depending upon, or I need a metallurgist, depending upon what is being considered as a team. But team leader who knows the technique, designer, operating man, maintenance man, these and plus the specific. This is normally a team, and we cannot compromise this. It's not that I can take two persons from production area and none from mechanical. No, I need to take a mechanical because functional knowledge is required within the team, and we will have, of course, team facilities as required. So let's get back to we have. Okay. One is we pick up a particular line. You see, within my whole design, PNI, we pick up a small section. Okay. It may be a pump and a pipeline. It may be a vessel. It may be some reaction condition. It may be a storage tank. So I pick up a small section. What is being done there? Okay. If, for example, I picked up a pipeline is flowing, there's a flow taking place. I ask the question, can the flow be under some situation, some condition, flow not take place? That means there is no flow. If that is the case, I ask this question together in the team. And that means we have picked up a small section of the PNI, and whatever is happening, it says, can it be that it does not happen? The complete negation of the intention of what is the intention is the flow to take place. Hello. Sarah is noise was from where? Okay.
Yes,
Maybe,
please.
yeah, it's gone, sir.
You are able to hear me now?
Yeah, we are hearing. We are hearing.
Okay. The point is, what was the intention? Intention in a pipeline is a flow. Flow does not take place. That's a question we pose with it as a group together. And comment obviously is no part of the intention is achieved, but nothing else happens. Okay. This is what is being there. Second thing is, will the flow be more? I ask you next guide word is more. That means higher than what is planned for or what is permitted. Can the flow be more than what is limit is? Okay. So this is next question which is asked, and it refers to quantitative increase. It can be temperature. So temperature more. Can the temperature be more? Can the pressure be more? Whatever the variable I am looking at. Or on the other hand, less. After asking more, then I ask less. Can it be less? Can the flow be less? Can the temperature be less? Can the pressure be less? Or can the level be less? Can the concentration be less? So I can look at my concentration. I can look at this. I can look at anything of that nature. Okay. So more or less are the guide words which we will be asking. Then we says as well as, that is whatever is required to be done happens, but something more than happens. That means in addition to this, something else also happens. So there's a guide word as well as. All the intentions are achieved together with some additional activity. Okay. On this is as well as is the next guide word. The next guide word is part of. That means what is intention, it does not fully happens, only part of it happens, but nothing more happens. Only some intentions are achieved, some are not. So can it be that there is a, transfer of material? So material is getting transferred, but not fully, only partly. Okay. Or reaction proceeds not fully, but partially. So that is what we actually pose a question. Reverse. Hello.
Hello. Yes, sir.
Can you hear?
Uh,
There is some noise, no?
yeah, it's okay now.
But do we know the source? Maybe someone that not muted, he can mute himself.
I hear mute here. I think, sir, your microphone has been some disturbance and listening some noise itself. Otherwise, everyone has seen here muted here.
Okay, okay. We can proceed ahead, sir.
Okay. I'm just adjusted my mic, but the noise was continuous noise when I was not speaking. Even then, it was coming. This is something else. While I have taken your point, and do mention it, I'll keep if needed adjust it. Okay. Fine. So reverse means what is intended does not happen, but the opposite happens. Flow is to take place in one direction. It doesn't go in that direction. It happens in the opposite direction. Okay. I was supposed to be cooling, but actually is getting heated up. Or poison instead of antidote. Okay. So D polymer isomers, optical polymer instead of L. So these are just opposite to what is needed. Can opposite happen? This is the next guide word. And last guide word is other than. That Is what is intended does not happen, but something quite differently, something else happens. Now, these words that we are seeing, okay, between these words, you can see here we have five guide words here: no, more, less, as well as part of 5, 6, and 7. These 7 guide words, between them, they are capable of discovering every deviation. Okay. And we are talking about at this moment a continuous process, that means steady state process. This is not applicable to, at the moment, what I'm showing you for a batch process. Batch process where we do, like pharma products often are done in a batch process. You take some material, close the cap, autoclave kind of thing, heat it for some, then hold it, then cool it, or filter it. So those are batch processes. There are different guide words given for batch process. In this slide thing, that will be coming up later on. But for a continuous steady state processes, these are like 7 guide words are enough to actually discover all deviations. Okay. Anybody has any questions on this? I'm making one very straightforward statement that these 7 words are capable of discovering every deviation in a steady continuous process. Okay, everyone agrees? Yes, Shri Krishna?
Can you more elaborate on this first no and not, this the complete negation of this intention meanings?
Okay. Now, when we are looking at it, supposing I talked about the flow in a pipeline. Okay. Flow in a pipeline is what I require to do. Intention is when a steady state, there should be a flow within these limits. So flow does not take place. That is, flow is 0. 0 means there is no total negation of the process. Okay. I'm second way, I'm changing the temperature, heating. Heating does not take place, but cooling is also not taking place. It's just hold. So no. In other words, I need to add heat before the heating, but nothing is happening. It is no heating at all. Okay. Level, I need to change the level. Level does not change place. It's stationary level. Okay. So these are what is actually means no. Is it clear, Shri Krishna?
Yeah, yes, clear.
Okay.
Okay.
But what I need for you to think out is these 7 words are capable of discovering all deviations. See, deviations are mostly going to create my problems. Okay. So I want to see that no deviation should take place, but in order to discover possibility of deviation, first I need to know this. What are possible? So these 7 words is capable of discovering all deviations. So this is what we have actually established. Okay, let's go to the next. I have mentioned the constitution of a team because we need multifunctional, because it is not one man or one function's job. And our output is not best based on one individual's experience. That means no human being, no matter how brilliant he may be, how hard he may have actually studied or gathered experience, analyzed everything, but even then he's limited because others can always add more value, and together they are best. So when I have a multi-function or one person from each function coming together, that means I have a best active combination of the competence or the knowledge. So actually this team constitution brings out the best knowledge which is possible to have. Okay, so we need to look at it, and since they are going to cause, we are going to have meetings. We should not be disturbed. So we need a place for sitting together, and we need to, before we do any discussions, we also need to actually and tell the people how they are going to do it and all that, because there are problems of attitude. Um, you can imagine very clearly a design engineer who was involved in design. Now his design is being actually, you can say, introspected or questioned by others. So when your own design is being questioned by others, he may have done a fairly good job, but then he's being questioned on his own design. So he has some kind of, you can say, defensive attitude. He's going to actually be defensive and make saying, no, this I've taken into account. No, this is there. So the point is, his attitude is not open. It could be a defensive attitude. Okay, so there are times these problems do come up, and we need also time. So no distraction, time needed. So, and constituent team is important. So when we start beginning with, we familiarize the team that what we are going to do. That means we pick up a PNI of a given process. Okay, so if there are many PNI, so we pick up one of them first, and second later, third later, and so we tell them what is the process going to be HAZOP. Okay, select item for discussion. Within the same, we select certain small item. Ensure each one understand what is being discussed. A certain design basis. There is a lot of information at this stage which is needed to others. For example, what are the design conditions? That means what are the limits under which we are going to work should be shared with all members. Normally, design engineer would actually have brought out this, and he would explain before getting into this. He says, we are going to do this. Here we are manufacturing so much of kgs per hour of this product, and it's going to move like this. It happens here, and this is the data. This is a material safety data sheet on this. This is a chemical things, other properties of this. So he actually explains. Okay, so when all that is being explained, that means you are certain the design basis is understood. Okay. Once having understood that, then they actually deviate, consider deviation and consequence step word by word, they apply and they actually debate it out. Explore the possibility, capture ideas, filter out the real concerns. There will be something which are minor. It will not mean nothing may come out, but something which is important, they need to actually take a note of it. So the team together is going to crystallize their thoughts on problems, getting agreement, and then record. We need to take all input contributions. Okay, this is we've been told in the beginning, but let me tell you, these are something which makes our HAZOP team effective. But I will come back to this kind of things later. Let's understand what we are actually doing it. describe the design, intention, operating conditions, etc. So whatever is chosen, what is supposed to happen is intention. Consider the guide word and look for deviation. Identify whether deviation, there is a cause which is present so that the deviation can take place. Okay, so note down the causes. If you have the causes and deviation is possible, look at the consequences which can happen and record it. And if the consequences are unacceptable, but it can happen, then you look at what you need to do. Agree on actions which are required and note it down. And that's complete a one guide word. Take up the another guide word, go back and apply. Look at all the 7 guide words one by one around this. And when all guide words are away, move to the next section and apply again all the guide words. So one section complete, and like that you complete all section. When everything is completed, you have your actually coming up all thing. This whatever discussions take place will be noted in the sheet, and you can say here what is the section being considered: guide word, deviation, causes, consequence, recommendations of the control, and reference number for further action. Okay, we're going to look at this condition, vulnerability and human part later. We will get into that first part. Let's assume we have a small continuous reactor, okay, and there is a material A and material B. Both of them are being pumped into this reaction vessel. It's a very simple reaction vessel, and product reacts quickly. It's a very fast reaction, typically representing one of the nitration processes. Okay, you can take any organic matter and you want to make it nitrated. Okay, so then this is what would be happening, like MNT, mononitrotoluene, okay, or dinitrotoluene. So or any of the nitration processes can be done. They react very fast, okay, and it's just a reaction. Bottom is taken out because reaction is fast, the product can come out continuously. There's a vent provided in case of any minor gases being accumulated, but it does not generate any gas. Okay, everything is liquid to liquid reaction. But overflow can take place if my reaction product is not discharged. It can go to safe place overflow. A comes from a tank and B source is not shown. And on the A material, there is a steam heating. This is heating or cooling. That means jacketed pipeline. Pump is jacketed and pipeline is also jacketed, because this material may be able to solidify, and I need to heat it out. Okay, so if I'm doing some kind of waxy material or high my component is more in the sense of hydrocarbon is high molecular hydrocarbon, it may tend to stick, it may tend to freeze things. So I need to actually provide steam heating. And pump also can be frozen. So I have provided a steam heating on the pump. Okay. The reaction is simple. A and B reacts to form C. Okay, whatever I've described, is it clearly understood? We are taking up a simple process, or a continuous thing. Yes, Shri Krishna, is it clear process?
Yeah, little bit, not so much, because you are saying the chemical reaction between two reactor. You are given some example.
Yeah.
In that. So you are showing the same slide, this 9, or you are showing different slides? I want to ask them.
I'm
Because,
showing same slide. I'm only
okay.
not giving you the material name. I'm only saying
Okay.
there is something called some hydrocarbon, and
Yeah.
we are probably calling it as material A.
Okay. Hydrocarbon. Okay.
Okay, and material B is like mixed acid or concentrated nitric acid, or that kind of thing. It could be, but is applicable to any general tool process, because we want to understand only the technique at the moment, and these kind of processes do exist. Okay.
Okay. Okay.
Okay. So A and B reacts to form C, but one thing we know is there's a part of the process. Component B must not exceed A to avoid an explosion. For example, if I was to make more acid, then the pH becomes high. Hydrocarbon, there has to be a ratio. Ratio of hydrocarbon to the acid must be within a certain small range. If acid quantity becomes higher than the ratio, to change the ratio, the pH goes to very low value, then it can explode. Okay, some of you may be knowing, even glycerin, when nitrated, it does very well like this. But when I do extra acid, it becomes nitroglycerin, and that nitroglycerin will explode. Okay, it's an explosive. So, and there are many similar processes out there. So we are only saying it is, in this case, there's an explosion possible. In some other cases, it may not be explosion, it may be only a fire. Okay, or it may be a spoiling of something else, or maybe corroding the vessel.
This
So I have a
the incident that has happened in Vizag is similar to what you are saying, no? Currently.
in Vizag.
Yeah, India.
That's right. I have not full information to what happened in Vizag. Okay, when they were making pesticides and all that. Pesticides also has certain things of this nature, but complete detailed information I do not have at the moment. But likely to be what you said is right. Okay, and these processes are create major issues because of pH, and pH is actually goes along with the ratio of the two materials. Okay, my process is simple. We can see all here. Everyone can see that process. Okay, now we want to apply our HAZOP technique on this, and whatever the dotted line, you can say pump and piping into the vessel. From storage tank, pump and piping, I choose this part of my initial inspection for my initial discussion as a HAZOP team. So the question I want to ask you is, there is a flow required to take place. Can the flow be not there?
I think there should be flow because it's a continuous process, and the amount should always exceed that of material B.
There will be flow, you're saying? No, question to us is not that there will be flow. Flow is supposed to be there normally. Yes. Okay. Under any circumstances, can the flow be zero? My guide word is no flow. I'm applying my no flow. Can the flow be zero? Chat box. Gajendra, can you help me in getting chat box?
Chat box कसरी आउँछ सर?
Chat box should be.
अंकजी अंकजी अंकजी
हेलो हेलो
यो chat box कसरी निकाल्ने?
chat box तपाईको त्यहाँ there is a chat box you have seen over there just a nearby participant you can see the chat box there okay हेर्नुस् त सर chat box भनेर लेखेको छ त chat box त्यहाँ क्लिक गर्नु त आफै आउँछ यता साइडमा
तपाईं गर्दिनु त तपाईं गर्दिनु
chat box okay just a minute म शेयर गरिदिन्छु त्यसो chat box भनेर छ त यहाँ तपाईको यहाँ chat box भनेर क्लोज गरेपछि
chat मात्रै कि chat box
can I share the chat box म शेयर गर्न सक्छु यहाँबाट
Please do that. Let's
Yeah,
share the chat box.
just a minute I am just I think maybe I am not sure I am just practicing here but I am not able to share you okay? I am not able to share you have not seen there is a chat box okay? I have already given you the access to the access as a host okay co-host I think you can easily see
1 second. Let me.
you can search click the chat you can just click the chat nearby the share you have seen the chat if you click over there okay you can see the chat there chat you have to close the number
Now it's okay, right?
you see
We are able to get the chat box here.
yeah okay
My request is for all of you 23 of us here today, I want to, if anyone feels that flow can be 0, point is flow can be 0 and due to what? Okay, then you write the cause, what can make the flow 0? Pump is not working, very right, and valve is closed, very correct. That can also happen. Pump is not working due to maybe electrical failure or mechanical failure. Pump can be seized, running condition, pump was running, suddenly got seized. Mechanical failure, inside, for example, the impeller inside gets dislodged and it gets seized. So flow comes to 0 immediately. Or electricity gets cut off and due to some fault in the electrical line, the pump becomes, again stops. That can also be there. Okay. A proper control mechanism, Shri Krishna, now this is not very clear. Flow can be 0, a proper control mechanism. What is a control mechanism? If you're talking about only the isolation valve, yes, supposing somebody was to operate the isolation valve and isolation valve is shut, then flow can be 0. That is true. Material A is finished in the tank is also very right reason. It can also happen. It was working normally and the level in the tank A was reducing and a stage comes, it loses priming because the level goes below the suction point. So that also can be there. So we can see here, there are number of possible reasons for which flow can be zero. Okay. If flow can be zero, so supply in the tank is empty, pump fails to run, mechanical failure, electrical failure, or is switched off due to some human error or mistake. Pipeline is fractured, was a possibility, okay, but flow does not go through. That means flow becomes zero. Isolation valve is closed. So when this is possible to happen, in that case, you will have B exceeding A. So B will, in that case, this has become less, the B will exceed A. And when B exceeds A, the explosion is going to happen. So point is, there is a very clear hazard present of possibility of an explosion. So this comes out fairly clear. Okay. We, at the moment, we are just identifying this. We will look at what, in a real case, how to take up, you can say, decision making. Okay. But logic, we can apply it like this, the way we have done that. Next is more. Okay. Can the flow be more? So how can flow be more? Yes, please write down your, type in your ideas. If the valve is not working, then flow is going to be less, not more. Unless we are, we might be saying my normal condition, my flow is, I'm actually throttle the valve, and when I fully open the valve, flow can be more. Are we talking like that? It's a continuous process. Ravi, it's a continuous process. So we are not actually going to change with the time. Okay. Steady state is what is being looked at. Yes, very right. Avdesh is very right. If the speed of the pump is actually increases, my voltage actually voltage increases, the speed increases, and then it can actually give me higher. High voltage is to high RPM, very right. So that can create high flow, very right. Temperature of the jacket will not cause the flow to be more. You might say the kgs per hour will remain the same, but volume may actually increase. But we are talking about the kgs or the quantity. So that is not, temperature will not affect it. Okay. Viscosity again will reduce the flow. Okay. So that means if there is a viscosity heating to take place in the jacketed and my required heating is not taking place, so there's a resistance because of viscosity, and my flow will reduce. But we are talking about at the moment flow to be more. So it's actually on a different guide word will come in. So unless we say the temperature is higher than the limit, and then the flow becomes more, but we would rather capture that under temperature because we are going to look at temperature as well. Okay, so we are going to look at the temperature, but you can note it down if you wish here. That means temperature effect, and that will lower the viscosity. Lower the viscosity means higher flow. Okay, so point is, it is possible, right? So it is possible to have increased flow. If it is possible to increase flow, and let's look at it, what will happen? More A is go into the kettle. Okay, this causes will be the characteristic may be such as to produce more flow. Okay, what is the consequence of this? Now it is the opposite way. See, if I'm doing more here, there is no explosion hazard. But if more A goes, my product C may be actually having.
Hello.
Yes. Yeah, please.
Hello.
Yes, I can hear. Hello, Mr. Batra, are you speaking? Hello. Who wanted to speak? Can you please speak again? I could not hear.
Maybe he's lost, sir. We can go ahead.
Okay. Okay. What we are trying to look at is when more of A goes, actually there is a contamination of A goes to the next stage. That means we have excess A present but no hazard. Or it may even overflow. The flow rate is right. So I might have overflow coming out here. My product is contaminated with unreacted A, and it will go into my next stage. But there is no explosion. From safety point of view, no incident or that kind of thing. It may be looked at from the quality angle, but process from safety angle, there is no issue at all. Okay, so this is possible, but it will not create any safety hazard. Okay, so now we want to look at less. Can the flow be less? Okay, now in this case, yes, you will find flow can be less. How can the flow be less? Isolation wire is gagged. Pipeline is active, blocked. Not damaged in the sense, but leaking way. Yes, if you say joint leak or other leak can be, but if it's a viscous material and partly is restricted, the flow can be less. Okay, that means inside there's a deposition of some solidified material and less flow goes out. Yes, not working properly also can be a problem. So can be there. If this can be there, then I again have a problem because B will exceed A. Ratio of B and A will exceed. Okay. So what is my issue? That means less is passed into the reaction vessel. Isolation wall is slightly closed. Pipeline is slightly blocked, or pump fails to produce the full flow. Pump can problem be there. So consequence again a risk of explosion. So that means there are umpteen ways in which this can actually happen. So I do run a risk of explosion. Okay. If I want to apply my next criteria, that is, we have done more, less. Now we say as well as. Okay. In addition to as well as, basically, what else can happen along with? That means right flow takes place, but something else also happens. Yes, anyone, any idea? Yes, Mr. Govinda? Fire. Yes, fire can be there on the vicinity or in the surrounding. That will be a possibility there. Anything else? Yes, anyone else? Anything along with can happen, as well as the flow, something else has happens. Fluctuation in the pressure. Fluctuation in the pressure, how does that affect us in terms of, and how can it happen actually, fluctuation in pressure? We have talked about the speed giving us more flow. We have talked about the speed giving us less flow. That we have already talked about from the pump point of view. We have looked at the pipeline point of view, leakage from the pipe. We have looked at material solidifying or within the pipeline. Fluctuation in pressure, why should it happen? Thickness of the vessel, okay, but again, thickness of the vessel, if you're talking about delivery vessel, that is not being considered. If you're talking about storage A, that is doesn't seem to be, and nor are we are not even looking at it. We are looking only pipeline pump from a tank to the reaction. Thickness will not actually cause anything of that kind. Okay. This A component which is given to us, we don't know the composition of it. Additional component may be transferred from other pipeline on the suction side. If you look back to this, you see here, there's a pipe suction line, there's another line connected. So I draw material from the pump by pump from the storage tank, but I can also draw something coming out from another branch which actually is connected to the suction of the pump. So that means I can take suction from both the lines together. So which means something more can also go along. Okay, so that is possible. Transfer is somewhere else possible, that is depending upon the pipeline connectivity. carrying out another activity concurrently which transfer, boil, or decompose. That means I not only transfer it, but I have overheating, so it starts boiling. Material is quantity-wise being delivered, but actually is boiling taking place. So depending upon that, we can, that means, mind it, this is overflow line at a certain point. So you can see here, the delivery is taking place by a submerged pipe. Submerged pipe means if there's a bubble heating, that will actually create bubbling inside. It may be not an issue, but it may be an issue depending upon my process. So identification is only this, that can happen. Okay, carrying out another activity which boil or decompose it. It can actually be decomposed at high temperature. So that is different. So we find the consequences are departure from this, but depending upon my process, we are not able to at the moment in this particular small example, because we are only trying to look at how to apply guide words. So in real life, you will be knowing what is to be done. Okay. Part of, yes, part of is also possible, but nothing else happens. Okay. A component A is missing here. Knowledge of the component A is required so as to assess maybe the omission of A to one or the more reactors. So component part something is being missing. Okay. Then reverse. Can the reverse be happening? Supposing our pump trips. If my pump trips, my delivery line is actually full of liquid and submerged in the reactor liquid level. And the level, if the storage tank, if it's lower than the level or in the reaction vessel, reverse siphon will take place. You're able to see, Ravi, that siphon in the reverse manner is a possibility in case the pump trips and valves are left open at that time.
Yeah, there are chances if the non-return valves are not fixed. There are chances of reverse
Yeah,
flow.
that's right. So that is also a possibility there. Okay, and what will be the consequence? It depends on what will happen. Okay, so it is a possible. Okay. Last is other than. That means transfer doesn't take place, something else happens. We already looked at as well as, but now this case other than means transfer does not take place, something. The transfer of a different material. My tank is empty, okay, and my tank is empty, it draws more material from here. So that means some other material is getting transferred. That can be, okay. Or change in the nature, A solidifies instead of being transferred. Instead of heating, I've actually opened a cooling water, chilled water valve. If there is chilled water connection also to the bigger hot jacketed pipelines, normally are supplied with the various kind of either steam, hot water, chilled water, or kind of things. So if I open the wrong thing, it might actually be solidifying. It will not transfer, but nothing will go, but something else will happen. So other than can be this. Okay. Now in this case, we have seen application guide words. Anyone would like to ask a question? How to apply guide words? Anybody has any questions regarding application of the guide word? Yes, very right. It'll be depending upon the situations. Everyone is comfortable in application of the guide word? Yes, but assume if that is true, it will be as a team decision. Okay, but the point is everyone member is talking, and if you are the, for example, hazard study leader, you are the one who's guiding application of the technique. So then will you be able to see that how to apply a guide word? And we have applied the 7 guide word one by one. Only, of course, very, very simple process. Okay, Kajendra, I'm asking you, are you also clear on application of the guide word?
Yeah, yes, I'm clear. Depending upon the situations, we need to use the guide word.
Right. So let me assure you, this is fairly simple. Okay, we have picked up, of course, a very simple exercise in terms of learning the technique. Okay.
So I think it's the matter of the skill we need to develop because if we apply this in the several contextual situations, then we will be clear what sort of a guide word where to use it.
That is right. Okay. Let me go next to when you are considering maintenance activities, because some of these activities also have to be done, it's not just the production or process thing. So then we ask other kind of guide words, what has to be done? Why? For what purpose was it? What if we don't do it? What else can be done? Or as well as this something more, or instead of this something else? So we ask this kind of questions to on a maintenance part. When this is to be done, why at that time? Why not earlier? Why not later? Where it is to be done? Why only there? Why not elsewhere? How it is to be done? Why that way? Some other way can it be? How much is to be done? Why that much? More, can we do more or can we do less? So all of this will actually reveal the, you can say, impact or consequences of it. It will show you something which is sometime hazardous situation. Okay, so applying all this actually helps us. How fast a job is to be done, the maintenance part, or why that much fast? Can it be slower or can be even faster than this? How often, frequency, why that frequency, why not more, why not less? Who's to do it? Why only them? Why not someone else? So what else can go wrong if deviation, does it matter? If there, what else can go wrong? And if there's a deviation, does it matter? These are basic questions you are going to ask. And how often you need to do that, and what then needs to be done. If there's a problem, then what that needs to be done. So you are actually going to ask this kind of questions to them. Okay. Subsequently, if there's a risk, you will obviously follow hierarchy of control. I'm not going to just read over it. Okay. And you have your ways of controlling. Okay. Now we want to besides the human part, which definitely needs to be there, because we need the right attitude. We need them to work uh, together in a very synergical manner. Okay, but we need to see inadequate design. There are some pitfalls. Sometimes a designer doesn't do good job. He say in any case, HAZOP team will discover it. That's not the intent. He has to do his good design. So this It's not a substitute. It is not a design carrying activity. Okay. Okay. Our debate streaming going too far. You are going into so depth and so detailed somewhere else. You sometimes get, you can say, straight far off than what you are trying to focus on. Experience is biasing your study. Okay. Pace and depth of the study makes a difference. Adequate definition of the problem. Okay. I want to give you one small part by application of this. Now, this is more realistic case actually happened in the industry. There is a hydrocarbon which is vaporized, oil vaporizer. Okay, there's an oil kind of things. Natural gas is used. There's a heater here. Okay, this heater, the oil is going within the heater through a coil. Liquid oil comes and heated oil goes out. Liquid oil coming, flow is measured and flow control valve is there, and there is an alarm on flow. Okay, no flow alarm is there, and also there's a temperature being measured, what temperature we need of heated oil. If the temperature is element teacher, so there's an interlock available on this. Okay, if the temperature goes too high, it can actually stop the TCV, temperature control valve, it trips it. That means temperature cannot go more than a certain limit. It will trip my natural gas heating into the furnace. This is a small kind of furnace kind of thing. Burners are going to trip. Also, there's a pressure switch. If the temperature is very high, then also there's an interlock and that will trip this valve. This is a pilot valve, and this is the interlock for this, and normal temperature is controlled by this. Actually, tripping is by interlock 4, interlock 5, I5, I4, and TE is my temperature element for control of temperature. If this is my thing and I'm going to do HAZOP of this, okay, actually I have my this is description what I have explained you just now. We are applying guide word no. Can the oil flow be 0? No oil flow. Element is oil flow. Deviation is no oil flow. What are the possible causes which can cause it? Supply failure can cause low nil flow. Flow control valve PCV is shut. If that gets shut due to anything, then also the flow will actually cease. Okay. Plugging of the coil can also create this issue. Blockage downstream of the vaporizer can also create this situation. So there are various reasons for flow to be 0. What happens if this deviation, what is the consequence? Vaporizer coil will overheat and may fail because burning of the fuel is taking place, but no oil is flowing within the pipeline. So there will be overheating of the pipeline and it will fail. Oil in the vaporizer will boil, whatever little bit there will boil, and overheating and cooking. When oil boils on, actually it forms coke. Coke will deposit on the pipeline. So that is also going to result. If this is the consequences, what are my safeguards? Low flow alarm. This is my at the moment already have. high temperature trip, I also have low flow alarm and high temperature trip. Both of these are actually my safeguard. Now, consider now, comment is safeguard depends on how quick the operator is responding. What is the action required? Consider low flow element Fe to close main burner valve. So that means there's a recommendation coming up. Okay, I think I have removed probably the chat box. Okay, but chat box by mistake is got removed. But the point which I want to say is, if we look back to our main recommendation is on this flow. If this flow beyond a certain limit should trip this wall, my heating must stop if my flow of oil actually stops. Otherwise, there will be a problem. So heating must stop. There must be actually tripping of the TCV wall, temperature control wall, by a lower limit indicated from FCV. I can take a value from flow element and trip this. So this is what we actually need to do. Okay. If there's no heat, that means burning does not take place, flame out take place. That means flame out is there. Okay. Unvaporized liquid will flow through. Now, if unvaporized liquid passes through the furnace, how will it affect the process? We need to look at. Consider interlocking furnace flame out signal with closure of FCV. So what is being recommended coming out by the people who did this study, it says if the temperature goes very low, no heating take place, then this should actually close this valve. That my flow must stop if the temperature is low. Request would be kindly go through this, which is actually a case study done of a realistic PNI. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, and all the guide words are considered on a small oil vaporizer. Oil vaporizers are there practically, number of them in refineries, number of them in fertilizer companies, anyone who's using organic chemicals or petroleum things, you'll find vaporizers there. So, and the design is quite similar to what is being shown here. So you can actually see this. Okay. I need to ask one question to all of you. This is a technique. It is a time-consuming technique, no doubt about it. And 2 hours is not sufficient for actually studying it. Normally, it takes 2 days to get appreciation of the course. Okay, so we have tried to put too much in a short period. You might say it's just bringing appreciation of the technique. You may not be getting skillful of doing this. Okay, so as long as your appreciation is one part, that means all deviation can be captured. Okay, so we are saying all deviations can be captured, all possible hazards related to design can be visualized. or even operational problem can be visualized. And then decision making by the multifunctional team can be done. Okay, so that means you are able to check capability of a design to deviate from the steady state conditions. In that respect, though time consuming, it is actually most powerful technique. Nothing will actually leave out, because these words are so deep into it. Yes, you need to apply your own experience, your own things. Okay, so but it will help you to definitely discover all that is needed. I'm going to, Kajen, I'm going to mail this to you. It has more part in this. Okay, in fact,
Okay, sir.
HAZOP for batch study, and there are guide words for the batch process. Okay, these are all guide words for the batch processes, and there's some application on the simple exercise of batch process. So you may actually read through this. Okay, so you can actually look at this batch process. That is all. The psychological part, obviously, I think I leave it to you. Maybe you can you want to deliberate at some other time, because people have issues in trying to. If I have one member who is not taking interest in coming forward his own ideas, then obviously team as it together is handicapped. Or somebody is all acting smart and doesn't let somebody else give his ideas. That again actually reduces the effectiveness of this. So there are cases of some depth study. We had looked at that in the beginning. Yeah. It's my design. So he is very defensive design engineer in the meeting. Somebody have general opinion. Oh, there's no problem. There's no problem. There's no. He has not experienced. Yeah, he doesn't go into depth. See, there are individuals who seems to be, for without any reason, being optimistic without basis. Okay, or someone big yawn man who doesn't participate, or overcautious, someone who is so careful, so doubtful, he goes and actually splits the hairs. So time consuming, time is, nothing seems to be ending. Overcautious man. Very shy man, he doesn't offer his own ideas. Dominant personality, somebody who dominates in the group. Now, none of this is actually, or even a non-stop talker. These are human-related problem. The guide team leader will ensure that this is not actually reducing effectiveness of your team. Okay, technique is powerful, but technique has to be applied by human beings. And let me also tell you, the best of the designs, and even of a major issues like shuttle going into the airspace and all that, they all undergo HAZOP studies, because these are able to bring out every change which is possible. And knowing what changes can occur, you will be able to take a right decision. So very powerful for design hazard, related hazard, the best. And it has the, but it'll take time. It's time consuming activity. Okay. Other thing which I need to just mention to you is You are able to see one variability diagram. Can anyone verbally confirm? Hello?
Yes, sir. Yes, sir. We are looking at, sir.
Okay. So Deepak, you can see here, if I'm looking at the pH as a variable, pH can be less, pH can be more,
Yes, sir.
pH can be as well as, okay. But there's nothing called part of pH. There's nothing called reverse of pH. Okay. Or there is a other than, yes, I'm going to look at. So depending upon what is my variable, we actually have a list. This is not a holistic list, by the way. You need to make it relevant to your own processes. Okay. So, for example, if I'm talking about electrical supply in certain, can my voltage be more? Can my voltage be less? My current be more? My current be less? Those things are not bringing out here, but similar fashion variability diagram can be made. We also have a standard on HAZOP today. Okay, I'll just show you that part of it. Okay. You see here, this is British standard license to someone, and you have your, there's a British standard and International Electrical Technical Commission standard, and hazards and operability studies application guide. This 61 pages guide is available to you as HAZOP, guidelines for HAZOP. So you may actually go through this. Okay, it is similar to what an ISO standards are. Okay, all your fundamentals are all given here. Okay, so you'll find every detailed information actually comes on to this. And Kajendra, I will email this standard also to you. Okay, some material has been picked out from the standard because this is what has been referenced as a all general when we learn the technique. Okay, and last is which we want to mention is this is this, you can say whatever the you have to have a format of this kind of nature. You may pick up one thing which is shown in the exercise will be quite acceptable, but what the technique does say minimum is this kind of things that we need reference. So that means you have your logic, guide words are well explained, the standard is there, you need to have variability, and once you have read through, gone over it, you will be familiar with. Okay, this familiarity is what it will tell you. Real life, it has given us a great benefit in the terms of see, whenever as a real life we go into any safety other activities also, we tend to actually figure out, can this change? Can it be different? Can it be more? Is there a possibility of this happening? Is it possible? So we mentally are able to look at of those deviations. Okay, so it makes us better HSC managers or better auditors. We actually gain on that account. But technique is to be seriously applied. Okay, any questions?
There is some questions. Deepak ji, you please put the questions.
I've lost the chat box. Can you help me in getting the chat box back again?
Yeah, yes, just click the chat so you can see, everyone can see.
Your questions you can bring up.
Deepak ji, हेलो दीपक जी
हजुर सर हजुर हजुर
तपाईँ
हजुर
होइन
सर
के
सुन्दैछु सर ए
दीपक
दीपक खड्काजी
खड्काजीले क्वेसन राख्न भन्नुभयो हो जस्तो।
दीपक खड्काले
हजुर
आवाज सुनेन हौ सर दीपकजीको आवाजै सुनेन
Yes, Deepak ji, you can put your question, please. Deepak ji.
I think Ravi Manandar ji has some questions, right?
I'm not able to see the chat box.
Can you please click so that you can easily see? Can you please click the chat and you can easily see chat? Can you click the chat? Just click the chat nearby screen share.
Next to the screen share.
It says pause, annotate, remote control, more. Chat is not appearing on my here.
Sir, why not we take verbally the questions?
Verbally I can answer you.
Yeah.
But you actually, Datashri had got us the chat box earlier. So
it is in the screen next to the screen share. There is chat. You can do the alter plus chat.
Okay. Now it should give a. Yeah, I think now we are able to.
So there is some questions.
Yeah.
One is from Ravi Manandar ji.
Yes.
So, right, it is defined in the standard that which process need to go through HAZOP.
HAZOP will need to go through whenever you are doing, the basic infrastructure change, hardware change. Okay, those changes is like a equipment design, equipment thing, installation. If you're going to modify that, or if you're buying new things, then HAZOP is needed. Not for other things, not for remaining part. So that is where absolutely must. In fact, new design, new plants always have to go through this. And HERA, if it's done, actually HERA is a general word. And HERA, for example, the way traditionally HERA is done, you cannot discover design-related fault in HERA. In fact, HAZOP is a subset of HERA. I'm saying subset of HERA, but HAZOP is a very detailed and specifically applied on the design-related hazards. And HERA otherwise cannot discover it. Please speak if you're not getting convinced. Management of change and HAZOP. Management of change is a method of authorizing a change, and HAZOP is a technique which must be done only after that the MOC gets completed. So again, HAZOP is an activity which will ensure the change that you are making actually will not create a hazard, will solve only the hazards. In fact, opportunity to reduce the hazards. So the method of reducing identifying hazards is actually HAZOP. So MOC requires HAZOP to be done. You're getting tab going through tab of more at the end of your screen. Okay, Netrabandhu, I'm not sure what is the issue at your end. Okay, but I'm going to email the whole presentation to Kajendra. Okay, and you can get to know from him. I have shown 4 documents. One was the main presentation, the standard variability diagram, and also one template in which you do the record sheet. this single page sheet. So these 4, I'm going to mail it to Khajendra later today in the afternoon or evening.
So,
Yeah.
let me have one question.
Sure.
There is also tools we will use for the risk side, like failure mode and effect analysis, structure what if analysis, or scenario analysis. What is the difference between these techniques and HAZOP?
No, your voice is not clearly coming out. I could not understand actually. Just speak a little louder.
My point is there is other techniques also for
Yeah.
the risk identifications, like failure mode and effect analysis,
Yeah.
scenario analysis.
Yes, yes. What
So,
if
HAZOP,
failure mode effect analysis? Yes, they are there. Or job
so,
hazard analysis.
yeah.
Okay. GHA, they are there. There are many
So,
techniques of that nature. Okay. But actually, each technique has its own ways. Okay. If you are going to discover the particularly design point of view, installation point of view, or things, or adequacy of your instrumentation, how much control you should put in, then HAZOP gives you the best. Okay.
But sir,
Each one of them has its own thing. For the operational part, okay. For example, if I'm going to write a operating procedure, then I will do JHA. I don't have to, I will not get into HAZOP at all. I will do actually JHA. If I'm going to look at a general word, I'm not experienced people, but they should be able to a kind of hazard and identification. Then what if is a very simple tool, but what if is not as in-depth study as HAZOP is. Okay, so what if will bring out something which are common experience for many, it will come out. Okay, so it will bring out FMEA when I want to improve certain failure rate. If something is failing repeatedly and I want to improve that failure rate, then FMEA is the right technique. So it depends upon what you want to achieve. Okay, if you are going to buy technology, if you're going to improve technology, if you're going to do design, I'm particularly using the word design over and over again, because there is no equivalent technique which can discover design related hazards easily. It cannot be. My process may work beautifully, functionally, only in some upset condition, some non-redundant wall actually would save the situation. And non-return wall is normal cases will remain open. It will not be brought out. You cannot find that there is something missing, but it is necessary in that process. So those kind of problems you will not find. Or making additional safety, foolproofing it. Foolproofing will come from HAZOP. Where do I need block and bleed walls? Where do I need my inherent safety concept going in? When my risks are high, I'm going to get into those. But the need where is supposed to be there, I cannot actually make a general judgment looking at the process or looking at some general data. I will not be able to make it out. So HAZOP is actually final answer to know what actually has a possibility of failure. But it's also time consuming. Please be assured, while it gives you the best output, it also takes a lot of time. Because when you start doing it, it'll consume time. Have I answered sufficiently?
Sir,
Yeah.
I have one question, sir. Especially, can we say that risk assessment normally doing for the qualitative risk assessment, when you go for the especially critical process method,
Yeah.
especially for the chemical industry, Can we say that HAZOP and like fault tree analysis, okay, this kind of the depth risk assessment or hazard identification method can be used for the quantitative risk assessment? Can we say that? Especially for the qualitative risk assessment, we can do the general scenario of hazard identification. For the depth, so can we say that?
See, those are qualitative, obviously will remain qualitative. It will not give you the full magnitude of the hazard, it will not come out. Plus, in fact, qualitative will not bring out all the possibilities. Okay. And the other one is quantitative one, which you do based on some HERA quantitative methodology, which is built up, numbers and all that. They do give you, but the point is, they are basically techniques to put quantification, but identification of hazard is coming from your experience only. What are you doing? It says, can this cause a hazard? You are putting from your brain based on your past experience, or someone else is doing it on that account. After that, you are putting, yes, what is the severity, what is the frequency, you are giving a magnitude. But identification of the hazard came from your experience. In HAZOP, actually identification process is very thorough and complete. You are not going to miss out anything. So that's very strong. And quantification will still be there. So you are going to put your quantification. That is true.
Okay. Thank you, sir. Thank you very much.
Thank you.
Krishnaji.
Yes, anyone else, any question?
Sir Krishnaji, के question थियो जस्तो लागेको थियो?
होइन छैन, अघि सोधिसकेँ मैले टेक्स्ट गरेर च्याटबाट।
अब के गरौँ त हामी मलाई चाहिँ धन्यवाद भनौँ।
क्वेसन छैन भने सक्दिउँ सर। अब विजय सरले के सोध्दै हुनुहुन्छ अघि? हेलो विजय सर।
हुनुहुन्न जस्तो छ।
देखिन्छ उहाँले के अघि क्वेसन त केही सोध्दै हुन्छ, हात उठाइरहनु भएको थियो है।
चार्टमा एउटा क्वेसन आइरहेछ सर। राजेन्द्र सरको चार्टमा एउटा क्वेसन आइरहेछ एके मिश्राजीको।
र भट्ट के अरे खगेन्द्र सर, क्वेसन हेर्नु देख्नुभयो राजेन्द्रजीको? व्हाट इज द टिम बिल्डिङ डेभलपमेन्ट रोल अफ HAZOP?
Can I repeat once, sir?
Team building development role of HAZOP. I think we may need to, there's a human angle to it. Okay, we get the best output from a different human being and different team members. Okay, it will need a lot of, I need to explain many points. Okay, I don't think time is permitted. And Khajendra, one thing more is I have been, maybe we can have another slot sometime to discuss a few things, but I am limited to actually there's something else coming up in some other companies through BSI, which I need to actually talk to the participant there. Okay, so I will not continue too long, but I can actually have a reschedule a meeting in case any one of you discussions.
We are very thankful to you, sir. You gave us a very valuable times today. It's almost 2.5 hours. We are very in-depth with your knowledge sharing, and hope that in the future also we'll be get in touch. And if you came to Kathmandu, please let me know so we can meet you personally. And by that time, our occupational health and safety professional network will be get the officially registered also. So we'll acknowledge your contributions to this our society. So thank you very much. Thank you from the all the members of this professional network. Hope to be in touch, sir. We are very grateful to your contributions, the valuable contributions towards the in-depth knowledge of the HAZOP to the Nepalese professionals.
Thank you, Kenneth, for all the good words. Let me tell you, this has been only just kind of familiarizing. Okay, I'm only bringing some appreciation of the technique. I don't think time was sufficient for deeply understanding all things, and and because I have a precious coming up from another angle, I'm not able to take up all your questions at this moment. But if anyone writes a mail to me, I will answer the questions on the mail, on the HAZOP right now. Okay. Surely I will answer every mail that whatever you send it to me on HAZOP, I will answer the mail without any difficulty. Okay.
Mail address is in his PowerPoint, so I will distribute to you people's.
Yeah. Thank you. I will do that.
Okay, sir. Very much thankful to you.
Thank you so
Have
much.
a good day. Take your, be healthy.